Hello everyone. Good morning to all of you. So today we have a slightly different setup because it will be our first practical lecture, and I will be teaching you how to navigate the SO-101 arm from scratch. Uh, so before I start, I would like to know how many of you are having the arm with you right now. So you can just type in the chat so that I can take a look at it. Okay, I have seen from the Discord group that many of you have already purchased the arms. In case you haven't, it is fine. This video, I will explain to you from the starting how to connect the hardware and the software. So first of all, what is the aim of uh, this bootcamp? The main objective is to implement the ACT policy on these robots, which I have here right now. And that is why the initial few lectures were totally focused on understanding how the ACT policy actually works. And now we have a very solid understanding of the architecture. So when we implement the policy, we will be able to understand the arguments used in the training process very well. And the debugging also will be easier. But before we even get into that, there are some intricacies which are involved in connecting this hardware. So it is not very straightforward. It is simple. Learnobo has made it very easy, but there are some minor inconsistencies that we have to take care of. So today I'll be explaining to you the entire setup, and I have done it a couple of times before, but I'll be doing it from scratch today. Okay, so let me start sharing my screen first. I hope you can see this GitHub repo which I have on my screen right now. I will share the link of this with all of you in the chat. So what we have done in this GitHub repo is that it's a fork of the Lorobo, but we have added a lot of information about what can go right, what can go wrong, how to make sure that your connection is correct and calibration, teleoperation, everything. Lorobo has missed a lot of details in these aspects where you can encounter issues. So today, hopefully, I will get a chance to explain all these things to you, the issues which I faced while connecting, so that if you are using a similar system or a similar interface like me, you will be able to understand these issues much better. Okay, so once you are in this repo, go to this section called resources. So there is a folder called resources, and within that we have several guides. So the first thing we are going to start off with is the installation guide. Okay, so before we even get started, let me explain what we have on the table right now. So these are the two robot arms which come along with the kit. Here is where I purchased both the kits or both the arms from. So I purchased it from this website and I selected package number 3. It took around 15 days to arrive since it comes from China and you have to pay the import duty as well with this. So overall it comes to around 350, I think, somewhere around that dollars. And within one kit you get two arms. You can see here there are two arms which I am moving right now. So some of you might be wondering what is the need for the two arms, right? So now these two arms have a very specific purpose. You can see here one arm has a handle which looks like this. It's almost like it is designed for humans to grip it and do some movements, right? So this is called as the leader arm. And the second arm, which is almost identical, but the gripper is very different, as you can see here. This is called as the follower arm. So these two are the manipulator arms, which are called as SO-101. You can also 3D print them, by the way, in which case your cost will be significantly lesser compared to what I encountered. Uh, okay, let me try changing the layout so that you will be able to see me in a separate way, but I'm not sure if that is hiding one of the robots. Okay, so yeah, so these are the two arms that we have with us. One is the leader arm and one is the follower arm. Now, one more thing you can see here is that I have clamped both these arms to my desk. And this clamping becomes very important because if you don't clamp it, the robot might topple down if you're moving those robots. So the kit comes with these clamps, which is used to clamp these down to the table, which helps in the control of these robots. So I have done the same. Additionally, you can see that there is one camera which I have mounted here. So this camera does not come by default in the or it comes by default, but it is not installed by default with this gripper. So they do provide some okay, can you share your video? Are you able to see my video? I think you can
Yes,
see it.
yes, 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 yes,
You can see it, right?
yes.
All right. Okay. Um, okay, great. Okay, so what I was saying was this camera module, which you see over here, you have to, they provide you with the nuts and the bolts for this. So you have to actually put the bolts inside and just tighten it with a screwdriver. So this is something which you have to do yourself. It takes 5 to 10 minutes to do this since you have to get a screwdriver, but the rest of the things are already provided with the kit. I will again explain about the camera module once we go ahead, but for now, just remember that you have the leader arm, you have the follower arm, which comes along with the kit, and you have to clamp both these arms down to the table before you start anything ahead. Okay, now what we have to do is you also get two cables, which are USB-C to USB-C cables along with the kit. And the purpose of that is to connect both of these leader RAM and follower RAM to your laptop. Now, one issue with that is I am using a Mac which has only two USB-C ports. So if I connect both of these directly with it, I will not be able to connect anything else. So to circumvent that, you can see I have a extension hub over here, which is used to. So this is USB-A type of connection, and one side I'll connect to my arm, the second side I'll connect to the hub. Now here there is another intricacy. The cable which comes with the kit, if you connect it directly, uh, the low robo software will not recognize that there is a connection. So you have to get these cables which are threaded like this. It's almost like a braided cable. And it is surprising that the cables that they give, it doesn't work directly with the hub. If you connect it directly to your laptop port, it does work, but if you connect it through any hub, it will not work. So this is a data transfer cable, which this is something which I found out after some time, because initially I was trying to understand why it is not working. So now what I'll do is, this is the cable, right? I'll connect one side to the hub, and the second side I will connect to my follower arm. The moment you do that, you will see a red light flash here. You will not be able to see it in the camera right now. And I will do the same for my leader arm as well. So I have to remove this clamp for now because it's obstructing the... Okay, so I have connected both these cables now, and the red light is, yeah, now flashing in both of these robots. Okay, all right. So we have connected the USB cables to both these leader and follower arms, and we have successfully connected it to the extension hub. This frees us space for us to work around with other ports. If in case you want to connect any camera module or you want to charge your laptop, you can do a lot of things. So this hub helps a lot. So the first step we have done is we have connected these USB cables. Now, along with the kit, you also get chargers. There is a 5-volt charger and there is a 12-volt charger. Now it is very important that you connect the 5-volt and 12-volt to specific places. For example, this is one user manual which comes along with the kit. And here it is specifically mentioned that the leader arm should be connected to 5-volt power supply and the follower arm should be connected to 12-volt power supply. And this you can actually see over here also, which is mentioned on the, there is a sticker which says this should be connected to 12-volt. Now, if you interchange this and make a mistake, it will not work properly. So now I am trying to find the 12-volt cable. Yeah, so this is the 12-volt cable which I have, and this is the follower arm. So that's correct. I'll connect it to the follower arm. And the remaining cable is the 5-volt cable, which I will connect it to the leader arm. So these are the two connections which you have to make to the leader arm and the follower arm. I'll just check if the connection is on or not. Yeah. Okay, so we have successfully connected the USB cable and the power also to both the leader and the follower arms. Now this is the first step, which is on the hardware side. We have so far not even touched the Lerobo software. Now what we are going to do is we are going to move on to the screen and we are going to understand how to use the Lerobo software. If you go to this repo which we have created, it's a fork of Lerobo, but it is much more detailed. So the idea of this Lerobo software is to make robotics accessible to all. And what does that really mean? Let's say we have learnt about the Act policy, right? And I want to integrate or embed the Act policy inside this hardware. Now, without this code, you will have to write the entire policy by yourself. So embedding policies becomes much easier using the Learrobo uh, GitHub repo and the software. The second part is they have provided a very useful Python package for a lot of different things. For example, if you want to do teleoperation, if you want to calibrate these robots, you want to record episodes, everything happens within their framework. You don't have to rely on any external packages. It is very self-contained ecosystem. So we will understand all of that and how exactly the low robo software works. And since we have already been done with the connections, I think we can safely move ahead with this now. Okay, so once we are on this repo and our connections have been made, we will go to the resources section, and the first section there is the installation guide. So in the installation guide, the first thing that I see is I have to clone the repository. Now, to do all these things, you need a interface where you can write the codes, and for me that is Visual Studio Code. So I'm going to open it right now. I might have to stop sharing the screen and start sharing it again because I had shared a window. So yeah, so I hope you can see the VS Code screen. Okay, great. Now what we'll do is we will open up, create a new folder where we will call it as low robo class demo. Open it. And here we will create a new terminal. Okay, so now these instructions which have been written have been particularly written for Windows, but I am using a Mac, so there is another link which I usually refer to for the installation guide, which is the link shared by Hugging Face itself. So this is another link that you can refer to, but for the installation purposes, I will refer to this link. For people using Windows, you can safely use the instructions which are provided in this repo. Okay, so now what is the first step? As a first step, we have to create a virtual environment using Conda. And to do that, there is this code which they have written here, Conda create. So let me just create it. Okay, so now we have to activate the environment, Conda activate le robo. Okay, great. So we have activated the environment, and now let's see the next step. Next, we have to install FFmpeg. This is for recording episodes and seeing the recordings directly in your VS Code window. So this is an important command for us. So we will run it now. Yeah, that's a good question, Viswa. Trying to set up in WSL environment, actually, one person in our team tried to do that, but they ended up with some errors after some time. So we can discuss about that separately later. Okay, so this is done now. The FFmpeg is successfully installed. Now the next is where we will clone this repo from Hugging Face. So on the left, you can see we have cloned the repo, and then you need to move to the learnable folder. So cd learnable, no such file or directory. Let's see. That's interesting. Okay. Yeah, it looks like I'm already inside the learnable folder. Okay, because I pasted both these commands. Thanks for pointing it out, Sriharsha. Okay, let's go ahead now. We are inside the folder. Now, the next step is important. We have to run this code pip install. So everything within the requirements file will be installed. Now here we will run into some errors. This is what I wanted to show you. Here you see it says no torch, no matching distribution found for torch vision. And this comes from this file where here if you look at, if you search torch vision, it says torch vision should be greater than 21 or less than 23. And that is where the mismatch comes in. The version in my laptop does not satisfy this. And for this, there is this thing which I replace it by torch vision greater than 17. Now let's run this again and see. Okay, so this is done now. Let's see ahead. Okay, so now we have installed all the requirements. Let's go to this repo and see if we are missing something. Yeah, so we do have to, log in with Hugging Face. So let me just do that. And the reason why you have to do this is because later when you record your data sets, uh, whatever your Hugging Face ID is, your data set will be stored over there. So this step is not to be skipped. It is a very important step. I'm just retrieving my access token. Okay, so you can see here that I have created a token and it's active right now. So this is an important step. You can do this later also, but it usually helps us when we record our data set. The data set gets uploaded to Hugging Face and then we can directly train that data set. So it's very convenient. Okay, it looks like we have done, it says install warndb also, but let me do that later. You can see I'm switching between this repo and that repo, but that's the way I've figured out to be the most optimal for me. Now this is another page where it actually tells you what to do next. So now so far we have installed the learnable package, but we have not made any communication with our hardware yet. And this is where we actually start to communicate with the hardware. So we have to tell Lerobo that, look, we have this hardware here and I want you to communicate with it serially. So before we do that, we have to run this command, which helps us to recognize and calibrate the motors later. Yeah, so this is done now. Now what we'll do is there are some step-by-step assembly instructions which are given here, but I did not use any of those instructions because this is mostly for people who have got the parts and or 3D printed the parts. So they have to basically set up the motors. Now the kit which I have bought, the motors are already set up. So the task becomes somewhat easier. I'll tell you the two main steps which are important now at this stage. The first step that is important is we have to find the ports. Now this is very important because both these robots are connected to two USB ports over here and we need to find the IDs of that ports. So for that, this is the command. Oh, yeah, le robo find port. So you go over here and do le robo find port. So it has a very interesting mechanism. What you have to do is you have to pull the cable, press enter, then the name will appear. So now first I'll pull the cable for the follower arm and then you have to also write it down somewhere. So let me just pull it. I pulled it, pressed enter, and you can see here the name appears like this. So what I'll do is I'll go over and I'll just note it down. Let's do the same for the leader arm as well. Okay. So we have the IDs for both the USBs. This is important because the hardware is communicating to your laptop through these serial ports, through these ports. So that's why these IDs are very important for us to recognize. So now this part is done, which is uh, finding the USB ports. As I said before, the configure motor parts is not important for us because the motors come with being, so they are already configured. So we don't have to configure them again. So now here we are in this hardware setup, and so far, okay, this is done. Find leader port. This is done. Okay, so now we will do camera a bit later. First, I want to show you teleoperation. So we want to control the follower arm with the leader arm. And to do that, there will be a command. Let's see. So in this repo, the approach that we have taken is the teleoperation happens when you record your episode. So it is happening implicitly if you go here. Okay, so I missed one step. Before we do teleoperation, we have to calibrate both these arms. So in this repo, the approach that we have taken is once you do the teleoperation, it will anyways ask you for calibration. So you can do it in the same shot. But first, let us do it step by step. So before we move to teleoperation, first we will have to calibrate the range of these 6 degrees of freedom. And for calibration, you have to move the arm to a specific position in the middle. So for example, here, this is the follower arm. If I want to calibrate this, I will move it to this position and then I will rotate it from all angles and I will calibrate it. Basically, I want to let my software know the range of motion for all these 6 degrees of freedom because those are the observations which will be passed to our AI policy. So this is the proprioceptive data which we want to pass. But to understand that data, we need to first calibrate, right? So that is the step over here. Now for the calibration, move to SO-101 again and let's see the, yeah, so this is the code which we have to use for calibration. Let's copy this. So robot type, let's keep it same. So here, this is where we have to modify the port of our robot. So since we are doing for follower, I'll be, okay, this is replaced. And you have to give the name, the robot ID. So let's stick with my awesome follower arm. Let's see. Let's run this. This usually takes a bit of a time to run, but it should not take more than a minute. Yeah, so here, let's look at the error. So it says a module that was compiled using NumPy 1 cannot be run in NumPy 2.2.6 as it may crash. So this is a again a version related error. and I have faced this error before. The workaround to this is to basically downgrade your version of NumPy so that okay, so let me run this pip install numpy less than 2. It gives some errors, but let's ignore this. It doesn't matter. Okay, so again we will run the calibrate command now. Hopefully this time it will work and we'll get to start the calibration. Okay, so it says command not found. I think it's related to some. Hmm, let me see. I think it has got to do something with the spacing. Yeah, so now it has worked fine. Okay, so it says press enter to use provided calibration file or press C and press enter to run calibration. So I will press C and press enter. Okay, so before we again press enter, we need to move this to the middle like this. Okay, now let me press enter. So you see these numbers now? These are the ranges. Now I will just move this. First I'll move, you can see these numbers changing. And you have to systematically move this, not randomly. So first I move this, then I will rotate this. Then I will move the gripper. Once all of these are done, you can start with the arms which are below. So I'll take this down and again take it all the way to the bottom. So it looks like we are done, but not yet because one degree of freedom is missing. We have to move the base also, right? So the base has to move left and right. Okay, great. I think this is fine. Let's press enter. Okay, so this is saved now. The calibration is working fine, and we have done it for the follower arm. Now let's start the same for the leader arm. For the leader arm, the commands are a little bit different. Let's go over here. For the leader arm, you see here, instead of this robot type and robot port, we use teleop. That is the main difference. So again, as before, I will copy paste this and paste it first in the Word. So this did not work for us. The bottom one worked. Okay, so this is the command for calibrating the leader arm. Let's copy this and first let's see if everything is correct. The port looks fine. It's matching with this and it's fine. Okay, let's go ahead. Okay, so again, let's press C and hit enter. And let's move this over here. You might see this mic, but it's the best position I found. So I hope you are able to see the calibration process properly. Okay, so again here we'll follow our same method. First we'll move the joints at the top and then we'll move backwards. Let's move the gripper now. Okay, now we'll move this. In the base, move it left and right, and I think we are done. Okay, so this is done. We have now successfully completed the calibration for the both the arms, the leader arm and the follower arm. Now the next step is straightforward. We have to run teleoperation. Now, why is teleoperation important? The reason teleoperation is important is, yeah, here is the teleoperation section. So teleoperation is important because in imitation learning, we have to collect data on which our policy has to be trained. Now, how to collect the data? One option you might think of is, why is teleoperation needed? You can directly move something and record it, right? And in fact, there is a lot of research which is happening in this direction. It's called egocentric approach, where people are arguing that controlling the leader arm and then recording the follower is a bit tedious. Why don't you directly record the human doing the task itself? And there is a stream of research which is coming out in this area also. But traditionally, imitation learning started out with this approach where you control the leader arm and you control the leader arm and the follower arm achieves certain task. To do that, you need a seamless communication between the leader arm and the follower arm. And that is why we need teleoperation. So for teleoperation, this is the command. Let me open this up over here. So le robot teleoperate. The type is SO-101 follower robot port. You have already found that port. The robot ID is my awesome follower arm, which is from here. And then teleop type SO-101 leader. Leader arm is fine. And then teleop ID is my awesome leader arm. So let's see. The moment you run this and it works, you will see the follower arm drastically move and to match the leader arm. So let's see if that happens. This also takes some time usually to run, but it's highly variable. I've seen it run fast. Yeah, did you see that? The follower arm, how it quickly moved to match the leader arm. Now you see here I'm controlling the leader arm and the follower arm is getting controlled. One interesting thing here is that if you stop the leader arm somewhere, this does not fall down because there is a torque being applied to it in the reverse direction. This is working fine. Okay, so we have successfully completed the teleoperation. Let us quickly revise what all we have done so far. First, we connected just the SO-101 arms using the USB cable to the extension hub. Here we notice that using this braided cable helps a lot. Otherwise, if you directly use the cables given by Wow Robo, it's not able to detect it properly. Once you connect this to the extension hub, you have to connect the power cables also. And the 12 volt goes to the follower arm and the 5 volt goes to the leader arm. Once that is done, we directly move on to LeRobo software. And within that, let's look at the repo to understand the steps. Within that, first we clone the repository. First, we actually create a virtual environment. Then we clone the repository. Then we install the LoRobo package. Here we noticed one discrepancy for the Torch Vision version. And we manually downgraded the version to 17 so that it works fine. We installed FFmpeg and we'll use Hugging Face. So we gave our login credentials Hugging Face. We gave it the token which will be used to save our data set when we record it later. So this is the installation step. After that, in the hardware setup, we have to find the ports, which USB ports these are connected to. And for that, we use the command learnable find port. And how to find the port is we first remove the USB cable associated with that arm, press enter, and then the name appears. And we do it for both the leader arm and the follower arm. And then we identify the ports for both these arms successfully. Now, after the ports are identified, we move with the calibration and the teleoperation. Why is the calibration important? For the ACT policy, one of the observations apart from the images is the proprioceptive data. And to understand the data, if you record observations, let's say you record this picking something and placing it somewhere else, how will it know what is the number of the observation? Every observation consists of a vector of six numbers, right? To identify those six numbers, you need to have a mechanism to let the robot know that, or let the software know that, okay, this is the number associated with this angle. So that is why we need to do the calibration. For the calibration, it is very important to keep it in the middle. If you start it from this, you can still do the calibration, but you will get negative values and it will ask you to calibrate it again. So after the calibration, we just run a simple teleoperation command. This will be incredibly useful for us when we record our data set. Okay, so this is the phase one of the installation. I hope all of you are clear with this. And yeah, Sriharsha is saying that he's using USB-C cables that come with it. Those also work if you directly connect it to the ports, but for me, it wasn't working if I connect it to the hub and then the hub to the laptop. So for some reason that was not working. And the moment I changed my port or the cable, then it was working fine. Okay, so now we'll do the next step and then we'll take a break before we move to the next part. But one step that you might be thinking of, okay, we have now figured out a way to capture the proprioceptive data. What about the image data? What about that? Right? So for that, you can see here, we have fitted one camera which comes by default with the package. And the resolution of this camera is 1080p. It's quite similar to the webcams. And in the ACT paper, actually, they have used, I think they have used three cameras or four cameras rather. So we'll be starting with one camera over here and we'll be understanding what to do with that camera and later how to add cameras also. Okay, so first, if you go here to hardware setup, you will see here it starts with identify camera indices. So first we have to run this command learnable find cameras. Here I want to emphasize that we can connect as many cameras as we want. For example, here I only have one camera connected right now. Actually, I do have another webcam also, so I think that also will be detected along with my laptop's webcam. So I'm expecting three cameras to be detected. But for the actual capturing of the data, one camera is not enough. I will need one more camera, which I will show you how to fit. But before that, let us Run this command learnable find cameras. So you can see the moment you do that, there is an outputs file created over here. And within that, there is a file called captured images. So let's first, yeah. So the first observation is have a look at this detected cameras. Now these indexes are very important for us. We need to note these index down. So how many cameras it is detecting? Camera 0, camera 1, camera 2, camera 3. So somehow four cameras are being detected, which is surprising. Let's see. Go to outputs and see the first PNG. Okay, great. So the first camera, I know exactly what it is. It is the webcam which I'm using to record. That is fine, which is index 0. Let's see the second one. Okay, second one is the OBS Studio, which I had recently installed, but I'm not using it right now. The third one is the webcam of my laptop. You can see it's very blur. I'm not using it that much today. And this one is it's surprisingly the camera which is connected to my arm is not being captured over here. It is capturing all other cameras. Now, why is that? So the cable which is connected to this camera has a USB port on the other side. So this I have not connected, and that's why it's not able to capture it. So I will connect it. I have connected it now. Let me just run it again. So I'm again running the command lerobo find cameras. And this time I'm expecting the number of cameras to be increased from 4 to 5. And you can see that is the case. Camera 0, 1, 2, 3, and 4. So there are totally 5 cameras. And yeah, so now index 0 becomes something different. Index 0 is what my camera mounted on my gripper sees. That is index 0. Index 1 is my webcam. Index 2 is OBS. Index 3 is my laptop's webcam. And index 4, I'm not sure actually what this is. I have to figure it out where this is coming, but I don't need it anyways. All I'm interested in for my application is only index 0 and also index 1, uh, because even though I'm teaching you right now with that webcam, that same webcam I can use to record my data or the collection of the data. So that will help me a lot. So to move ahead, we just need to note down these indexes: index 0, index 1, index 2, index 3, etc., or whatever indices we are using. Okay, now before we move to the next part, I want to show you how the second camera can be connected. Now, one thing we know for sure is just having one camera here is not enough. We need another camera. So to do that, what we had done is we had actually got a ring light here. And the objective of this was to place it very close to, so it captures the top view. Okay, for now I have just connected it for the sake of understanding. But let's see what happens after we connect this So this is my second camera along with my gripper camera, and this is interfering with. Okay, but it's fine. Let's see. Have I connected this yet? No, right? So I have to connect this first to the USB so that it's the low will detect it. That's why having extension hubs help a lot because they give you a lot of scope to work with. You can connect different cameras as well. So now there is an option for you to connect a camera like this, which sees it from the front, but also you can connect it from the side as well. So you can have a front facing view as well as a side facing view, but let me just run this and see what is my webcam actually seeing. So now there are one more camera being detected. Let's see. So ID0 is again for my gripper camera, where you can see a shadow right now because the light is coming from my left hand side. So the shadow is formed below my gripper. Now camera 1 is exactly what this webcam identifies. So imagine a setup where you're doing a pick and place, right? And for your pick and place, what you need to do is, let's say we have uh, we have an object over here and we have a plate over here. And the objective is to uh, move this arm in such a way that it takes this cube and puts it in the plate. Now, if you just have the gripper camera, it will only have a very narrow axis, right? That is why you need to have a camera which captures different views. Now, this view, what it does is it allows you to capture both the cube and the plate very nicely. So let's see if that happens. Let me again run this and we can see what is seen in the field of view. Okay, 0 is again gripper, but now here you see it sees the cube and it sees the plate also. And ideally, you want it to see only both those things along with the gripper. You don't want it to see, for example, I have a laptop over here. I have wires hanging out from the left. You want to clear all of that. But for now, since I'm showcasing this as a part of the lecture, there might be some uh, things here and there which are probably not essential for us. But when you do your setup, make sure to remove all these things which are not required in the field of view. So for now, we are going to stick with these objects, and our objective is going to be to pick this red cube and place it in the plate, basically. Okay, so this is something which you can tweak, but let me keep it fixed for now. I don't want to move it that much. Okay, so up until now, we have done our setup. We have done with teleoperation, and we have also done with the camera setup. Now we can safely go ahead for recording the episodes. But before we do that, let me stop sharing my screen and ask if anyone has any doubts or any questions with respect to what we have covered up until now. Okay, so now the natural next step for us is to get started with recording the data set. And let's understand how that is done. So if you go to this repo, there is a section called dataset recording. And here, let's try to see what all is given. The dataset recording captures the robot joint positions, camera images, leader arm movements, and timestamps. Every demonstration is called an episode. And before we start with the recording, we have to cover the installation, hardware, and the calibration, which we have already done. And before recording, set up your task, place objects in their starting positions, position cameras. So I have two cameras, one you can see, one probably you cannot see, it's up here right now, where my hand is. And from there, the camera is looking at my objects. Uh, Try the task with teleoperation a few times, remove anything that might interfere with the robot. I have some things here which I ideally would not have had, but since I'm recording this lecture, I have some constraints. But before you start the recording process, make sure that whatever your cameras are seeing, it is very clean. It does not have any wires, and it is focused on the specific areas which you want your policy to understand. Okay, understand camera indices. So this we have already looked at. Let's again understand this. For us, there are two camera indices which are important. Camera 0, which is looking at my gripper, is I'll just move the gripper a little bit because the cable is coming in front of the gripper, which is not at all ideal. And the second is this, which is captured through my webcam, which is mounted on top. Here also my laptop is coming, which is again not ideal. But yeah, so you have to make sure that these are indices 0 and 1 for me. So I have two indices. Index 0 might be your laptop webcam, but here it depends. For me, index 0 is my gripper and index 2 is my webcam. Now for recording the data set, there is a line in which you have to write robot cameras. And here you have to write camera name 1 settings and camera name 2 settings. So let's look at the settings, okay? So first I'll maybe show you the command which I used for doing the recording. Okay, so this is the command I used for recording, which you will find in the documentation also. So here it says Le Robot record. This is fine. Robot type SO-101 follower. The port of the robot, we have already identified this. Robot ID, we have already identified this. Now here the important thing is over here, which is the robot cameras. Now I have two cameras, camera 1, camera 2. Let's look at camera 1. The type is OpenCV. How do I know the type is OpenCV? You can see it written over here. OpenCV camera, OpenCV and OpenCV. So the type is OpenCV. Now the width is 12807. So this is something which is tunable. Now remember in the paper, they have used the width and height to be 640 and 480 for all the cameras. And initially, for this, right, I had 1280, 1920 and 1080, which is like a very high resolution, right? Which you might think it's ideal because then you will have more pixels and you have more data to learn from. But the issue is that it becomes very slow. And sometimes the training might stop abruptly. It might be because of my laptop configuration also. So I changed this to 1280 and 720. I reduced it from 1920 by 1080. And these are the frames per second, which you have to mention. I have mentioned it as 30. And camera 2 is again type is OpenCV. Index is 1 here, as we have seen before. and the width is 640 by 480. So you can actually change this width also. So let me actually try it by changing this width. It might be better. Okay. And then the rest of the things are teleop type, SO-101. This is fine. ID. Yeah, this is the dataset repo ID. This is where your recordings will be saved. So modern robot learning class. One number of episodes I have given as 5, and the task is pick and place. Let's go ahead and paste this and see what we get. It is taking some time for it to run. Let's see. Yeah, it looks like it has gone ahead. Yeah, I hope you can see the screen which says rerun.io. And
recording episode 0.
Yeah, so now it says recording episode 0. And you can see I'm controlling my leader arm, and I want to show it pick and place. I think this is very far. I'll just move it a bit closer to this. Yeah. So what I do is, while recording, you should never look at the actual footage, but you should always look at what your camera is showing you, because that is what your AI model is going to see. I grab it, I pick it. So my mic actually comes in between, and then I place it over here. This is one episode. Not very good, but if you want to accept this episode, you can press right. So I
Reset the environment.
So it has accepted this episode, and it says reset the environment. Now I'll again place this. I'll place it somewhat close. Okay, I pressed the escape key by mistake, which is why it is stopping the data recording. Anyways, I wanted to start it again. So
Stop recording.
okay, let's do it properly this time. It is still uploading my data on Hugging Face, which is fine. But I'll just change this name now, and I'll record it again.
Exiting.
So this time I've kept my cube close so that you can handle it properly. And I am also moving my leader arm slightly to the right because it's getting hindered right now with the mic. Okay, hopefully now I'll be able to do one smooth recording. Let's see.
Recording episode 0.
So recording episode 0. Okay. Now you can see I am always looking at the screen. I am not looking at the images at all, the actual object. Okay, bad. So ahead again, pick it. Not very good again. This is a very bad recording. I'll press left.
Reset the environment.
When you press left, what happens is it discards the episode completely.
Recording episode 0.
Okay, let's. Okay, good. So now I'll press right. I'll accept this episode.
Reset the environment.
This time I'll try to do it smoother. So while you're recording, make sure to place the cube in different positions. The reason is that you want the model to generalize well, and that's why you should cover as many positions as possible in on your table where it's picking and placing it.
Recording episode 1.
So recording episode 1 now. 0th episode is done. You can see I'm getting better at it slowly. Okay, done. I'll accept this episode.
Reset the environment.
Now I deliberately place it like slightly closer, maybe over here. And then I'll again start with the recording. For me, it takes some time to move from one episode to another for some reason, even though I press right. But let's see. So I need to wait for some time before the next episode starts. There might be an optimal way of doing it, but this is what I've figured out until now.
Recording episode 2.
Recording episode 2, let's see. An easy one.
Reset the environment.
Press right key and it asks me to reset the environment. So I again press the right key now. And you see this map. This map is where it is mapping the recording to observations and actions. That is what it is doing in the background. Now the episode will start again. And this time it will be episode number 3, I think. Let's see.
Recording episode 3.
I'm opening it. That is my strategy. I'm opening it and going down. grabbing it, placing it there. Okay, done. I'll again press the right key
Reset the environment.
and reset the environment. Maybe place it a bit towards left right now. Again, I'll press the right key. So again, the mapping will happen, I think, over here. So this is where it maps this to observations and actions. Remember, in the ACT architecture, on the left-hand side, what goes to the encoder is the observations and the actions. So that's what happens over here. Okay, let's get ready for the last episode now.
Recording episode 4.
Holding episode 4. Okay. Slightly tricky because I don't have a good view over here. So I look at my camera 1 actually. That is better than camera. This was a bad episode, but it's fine. And let's see. So 5 episodes are recorded. I will press the right button again. And now you can see here, it will actually push this entire data to Hugging Face. Now, there are some very key things which we have to keep in mind while recording this data. The first thing is that our actions should be very smooth. It should not be very jerky. We should have a specific way of picking, grabbing the object and placing it in the box, and we should maintain that consistency throughout all the episodes.
Stop recording.
We need to make sure that the different positions are covered. What we have done in our ACT recording is we have divided the table into grids, into 7 or 8 grids, and we use 8 grids for training and we use 4 grids for testing.
Exiting.
So what happens is that during training, you do 5 episodes in each grid. So 8 into 5, there are 40 episodes during training. And then while you are doing testing, you can test it within the training, which is the in distribution testing, and out of distribution, you can test it on the remaining 2 grids, which are not seen during training. This is where you can evaluate whether your policy has generalized well or not. Okay, so it looks like this has been uploaded. Let's check on our Hugging Face to see if uh, yeah, this is the one. Yeah, MLR class 2. So yeah, this is where our data should be uploaded, and we will use this same data set for training as well. Okay, this takes some time for the data viewer to be available, but I'll show you some of the other. For example, this was a run which I did where the data set is created like this. Let's try to see if we understand this data. Okay, so the first is the action, which is a series of 6 numbers because it is 6 degrees of freedom. Then we have the observation. So for every observation, you can see that the action is what is the next step? What are the observations in the next step? That is what action means. It is very similar to in an LLM. When you are at the current token, the next token becomes the action for the current observation. Similarly, for this observation, this is the action. And you saw that map function, right? This is where it is mapping the observations to the actions in your entire trajectory. And basically, that's all this data set contains. It tells you the names of this 6 degree of freedom. And it is interesting how the data is actually coded here. Let's explain very nicely in this GitHub repo. So if you go to this GitHub repo and you look at You look at this dataset recording. Uh, the format in which the data is recorded, let's see where that is mentioned. Okay, there is a very specific way in which these files are saved. Probably this is not visible here right now. Okay, so before we go to that, let us quickly revise how we recorded our dataset and some do's and don'ts. So firstly, once you run this command, the camera windows will appear. You will see live feeds from all your cameras. You need to follow the prompts, press enter to start each episode, perform the demonstration, and to accept the episode, you need to press the right key. To reject the episode, you need to press the left key. And if you press escape, you will stop the entire recording session and record it again. For me, when I press the right key, it asks to reset the environment. So if you wait for some time, it will automatically reset. Or if you again press the right key, then it will reset faster. Okay, how to handle a bad episode? If you make a mistake, press the left arrow key. The system will ask you to reset the environment. Again, press the right arrow to continue recording the next episode. If you want to stop the whole session, then press escape. Now, this is very important. Always watch the camera. We have a tendency to watch the robot, what it's doing, but that's cheating because the policy has only access to what the camera is seeing. So you should not cheat by looking at the robot. You should always look from the eyes of the policy. This is very important. Then there are ways to manually upload episodes later as well. You can use this key for that. You can use this command to do that, and you can manually upload it to Hugging Face. But for now, for us, it is automatically uploaded to Hugging Face as you just saw right now. Now, one interesting thing is that we can actually verify our recording. So let me actually do that. It's very interesting. So you can use this command where we can replay our episodes. So this is MLR. MLR class 2. Yeah. So now when I run this, you will see this robot, it automatically starts moving because it will replay that episode. This I find very cool actually. So it's very interesting to see this on your own hardware when you see it for the first time. Yeah, those are good points which Sriharsh has raised. So there are two things. You need to remove the cover on the camera before you mount it. And the second is you need to adjust the focus also. Otherwise, you will see a blurred output. So now you will see
Replaying episode.
you can see the follower is automatically moving. So this way you can cross-check all the episodes to see whether it works fine or not. So it grabs the object and then it puts it back. So this is episode 1. This looks fine. Let's see episode 2.
Replaying episode.
I'll just play one more so that we are satisfied with the data that we are recorded.
Replaying episode.
Okay, great. So we are done with recording the data set, and it will be uploaded on Hugging Face as well. Let's see if it is done. Yeah, you can see the data is available here. Now, what we will do is the next step is to train the data or train our model. Sorry, we have to train our AI model, our policy based on this data set. So let's see our repo and see the instructions there for training. Okay, so first I will start with option number 2, which is runpod. And the reason I'm starting with runpod is because I think it will be a good short tutorial for all of us to understand how runpod works and uh, the value it provides for if you want to run applications on a GPU. So I have tried it using runpod. It's possible to train it directly on your local PC as well. But we will start the training on runpod first. So yeah, let's look at this training on runpod. So before we start, let's go to the runpod website and understand what it is. It's a place which allows you to rent GPUs. So depending on how powerful the GPU is, you end up paying different amounts based on the power of your GPU. So now here I click here, runpod. It looks like recently they have changed their UI. Let's see. Okay, so I have logged into runpod, and here you need to go to this section called pods and click on deploy. So once you click on deploy, what will happen is you will get a chance to select the right GPU. Yeah, I'll give the referral link as well to this. Um, I'm not sure where that is, but I have to take a look. Okay, so let's look at the GPU that we are going to use. We will use the RTX 4090, which costs around $0.59 per hour. It will take us roughly an hour or even less than that to train our policy. So we'll click on this, and we only need one GPU, which has already been selected as GPU count as 1 over here. and we will click on deploy on demand. Okay, so now what we will do is we have to run everything through VS Code, right? So we will be connecting through SSH. I will just take a minute to open up some things, just a minute. Okay, so this is the config file in which we have to make the changes. If you see here, we have to copy this as the host name, and the port ID is also different, which is 10208. So I will just copy it over here. And then you have to do connect to host. So here I'll click runpod 19 because that is the name that I'm using. I hope you can see my screen right now. Now this is a Visual Studio Code, which the interface looked same, but I'm running it on like remotely on my runpod server. So at the bottom it says opening remote and now it's connected. So I'll go to file and say open folder, and here I'll click workspace. Okay. Now we have to follow certain similar instructions as we did for initial when we set up the learnable library. We have to do something very similar here. So let's go to the instructions and try to see what all is provided. Okay, so first thing is to clone the repo. So let's see. Yeah, and I'll maybe directly let's see. Yeah, let me directly get started with this. Yeah, so I have cloned the repo now, and after this I've also changed my directory. So the same step we have seen before, and now we are doing the same thing in runpod. Okay, great. This looks good. Now our command pip install e, which is what we will run. Now here we will not get that torch vision package mismatch error, I think. So we won't have to make any specific changes as such. Now, parallelly, if you want to see what's going on in the run pod, you can go over here and see your pods and click on telemetry. So you can see the disk usage, the CPU, GPU currently we have not even started using. So it says VRAM usage as 0%, which makes sense. But this will ramp up once we start training our policy. Okay, so let's see what happened over here. Okay, it's still in the installation phase. I will be sharing this recording after our lecture today. So even if you're falling behind right now, it is fine. You can still catch up. So it looks like this is done now, which is great. Let's go ahead and look at the next part over here. Okay. Okay. So once we have set this up, I think we are almost ready to start our training. But before that, we need to do some things. And the first thing that we will do is we will install 1DB. Um, and let's see, because we need to track our progress, right? So we will definitely do that. Oh, let's do that over here. Okay, requirement already satisfied. Okay. Yeah, so once you do want be login, it asks you to enter the API key. Uh, where is it? Yeah, I have logged in so that my progress can be tracked, and it will give me a project link also when I start the training. So I think it should be fine. And yeah, so this is done. Now we need to again uh, also log in with Hugging Face. Okay, so I have logged in Hugging Face and won't be also. Now I think we are good to go. Let us start with the training script and hope that it works properly. So I might have written training script somewhere. Hmm, where have I written it? Yeah, so this is the script that we will use. Let's put it out on our document and see if there are any changes that need to be made. Okay, so first of all, dataset repo ID, which is the dataset it will use for training. So the repo ID is different, right? It is some MLR class 2, I think. Let's see if I wrote it correctly. Hmm, MLR class 2. So I have written MLR class 2. Okay. Policy type is ACT because we are doing action chunking. Policy device CUDA. Output directory, let's do something like act policy pickup, modern robot learning 1. And job name is act policy pickup. Policy repo ID, this is the name of our policy when it will be stored. So this is fine. Batch size 8, step size is 30,000. It 30,000 takes some time, so let's start with 3,000 and save frequency is 500. Want DB enable true. Okay, let's copy this and paste it over here, and hopefully things go fine. Let's see. Okay, so I've pasted this command and I expect the training to start now and the metrics to be logged in properly. Yeah, it looks like we are good. Okay, no such. I think FFmpeg was not installed, right? Which is something we did not do when we were running the installation. So we need to install FFmpeg as well. What if simple pip install FFmpeg works? We try that. Not sure if this will work actually. Yeah, let's run it again. Let's see. Okay, so we have done this FFmpeg and oh, this error I've got before. It says output directory already exists. It's fine. We can just change these names. Okay, now I think things should be smoother. Let's see. Yeah, there's some different command for this. Okay, hopefully this will resolve the issue for us. Okay, great. Now let's in okay, let's see one more time. Okay, I think now it's working because we are not getting that error anymore. And I want the training to start now as soon as possible. Till that time, let's go to this link and see our wand. If we are able to access it and track our metrics. But since the training has not started, we might see something as empty over here. Yeah. So you can see it has actually started the training. For the first step 200, the loss was 6.833, and then the loss is gradually going down 2.888, 2.439, and we have selected only 3000 steps, so it should be done pretty fast. Let's see. Let's see the training statistics over here. Yeah, you can see it's updated now nicely. The loss started with 6.8 and it's gradually decreasing, which is amazing. Means that the ACT policy, we are actually training it on the observations and actions with the same architecture, which spent a lot of time understanding, but now it's all coming together very nicely. How many demonstrations should we record? I think we should, in the paper, they do 50 episodes for even the most complex tasks, so that should be enough. Yeah, so we should maintain our setup, the camera location, follower arm setup. There should be a separate space dedicated for this. Ideally, you should not mess with it too much. And we are training this model from scratch. So we are training an ACT model from scratch. We are not fine tuning any model. This makes sense because We are using a transformer architecture, which we looked at in quite some detail in the last lecture. So we are not using any pre-existing LLMs or VLMs or VLAs trained on specific data set. So, which is what makes this very interesting. It's the perfect point for us to start training or start learning about modern robot learning because it gives us a lot of confidence. You can see that most of the things in this field of robotics is also AI driven, right? The hardware component was small. Finally, it ends up being how well the policy performs on your data set. And then all your AI ML knowledge will come in very handy over here. So we are at step number 2000 right now. I think we are almost, will be done soon. So I have ran this for 30,000 steps and you can even run it more than that. The loss should finally go down to 0.05 or 0.06, something like that. If you look at the original ACT paper, they train it so much that the loss goes down even more. So now the loss has dropped down below 1. It's looking good now. So the setup on the runpod was pretty easy, right? It did not take much time for us. We just have to install the learnable library and the FFmpeg again, and then we are good to go. So if 1 hour it will cost you, I think $0.5 to train this entire thing. You can also do it very easily on your CPU. But I think this is important for us to be familiar with runpod because later whenever we'll use VLAs or other models subsequently in our course, in the course of learning robotics, I think it's useful for us to understand how it works. So this is done now. The policy is being uploaded to Hugging Face. So Google Colab I did not specifically use because of the limited GPUs available there. And also I like to do the coding in, I like VS Code to be my interface where Google Colab is restrictive. It's like one single file in which there is everything. So it doesn't really help me that much. Although now you can install Google Colab in VS Code as well. So that might solve that issue. So let's see. I use runpod because it makes it very easy. It's very fast also, as you saw right now. The final loss is 0.779 and it's continuously decreasing. And the loss is divided into two losses. The L1 loss, which is the reconstruction loss. We have discussed this before. Reconstruction is where you're trying to match the actions, the predicted actions with the true actions. That is the reconstructed loss. And next you will see a KL loss also, which is the KL divergence, where we are trying to make sure that the latent variable is a Gaussian distribution centered around the mean, centered around 0. So this also drops down very nicely. Okay, so the loss you can actually relate to the understanding which we have covered in the lecture, and you can track both the types of losses L1 and L2 over here. The L2 loss in particular is dependent on your style of training. For example, there was a specific way in which I moved the cube, right? So there might be variations in the proprioceptive data which I want to capture in the latent variable, which is what is generally taken care of in the encoder side. But I don't want to go into too much detail in today's lecture because it's meant to be very much practically oriented. Okay, so I think we are done with the training. Let's see if this appears in our models. Let's see. Yeah, yeah. So it does appear in our model, you see here. act test pickup policy MRL3. So it is uploaded, and this is our model which is trained on a specific data set, which is excellent. Now we are almost done. Now, after the model is trained, everything is done. We have done with all the major things. Now the last step is to run inference. And let's look at the instruction guide for running inference. So these are just some instructions for training policy type, policy device. We did not actually use this, but you can also mention the chunk size, which is how many future actions it predicts at once. Policy repo ID, this we looked at. Then the training configurations, batch size was 8 in our case, steps was 3000. Safe checkpoint. What does safe checkpoint do? Here, if you see that it creates a, where is the, it creates an output folder. And within that output folder, you see here checkpoints. We have checkpoints at every 500 steps and on last. So all these checkpoints at different policies are available to us. What people generally do is that they choose the checkpoint which gives them the lowest loss on the validation set. But for us, we are not running a validation set right now. We are only running the uh, one single training set. So we are going to use the last policy. One drawback of this approach is that it might happen that at this policy your model is overfitting on the data. But let's go ahead with this for today's lecture. And then weights and biases, we have already looked at how to log the data. This we have seen. And the outputs, the checkpoints your training will save every how many number of frequency you have for saving it. And then finally, once your test training is complete, you can test your policy by running inference, in which the code is very similar to the code which you used for recording the data. The only difference is here you are giving a policy path over here, which is what is the model which you have trained. What is different from the recording? The new option is policy path and policy device. This will load your trained policy and run the robot autonomously. No teleoperation required. And this is run locally because I'll show you how that is done. You can even resume the training if interrupted. Okay, but for now, let's see the command which we will use for. Okay, so for running inference, we will again switch back from runpod to our local setup. And we'll use this command. You can see this is very similar to what we looked at before for recording episodes. Learnable record, robot type, SO-101 port. Okay, this is cameras also stay the same. Oh, I think we use 640, 480, right? So we should change it over here. 640 and 480. And let's say number of episode is only one. I just want to record it for one episode. And the policy path is this. I think this was MRL2 or something like that. Let's see. Act underscore test underscore pickup underscore policy underscore MRL3. Yeah, I think this looks good. And this is where we want to save our data. So I think this looks fine. So there are a couple of questions in the chat. The first question is, would it be a good practice to make grids? I think it's definitely a good practice to make grids, but those should be for your own reference. You should not have the camera see the grids, but you should know where exactly you have. The use of the grids is finally for you to make a very robust analysis in training and testing. For example, as I said before, the table which you are seeing in front of me right now, if I divide it into 10 grids and I use 8 for training, and within each grid, I have 5 episodes. Okay, so there are 8 into 5, 40 episodes which I train, and the rest of the 2 grids you can use for testing to verify if your uh, how well your robot works on out of distribution data also. So this way it will really help you to record the data in a very efficient way. And the second question is about lighting conditions. As I said before, we use the ring light because it helped us to very accurately control the light as opposed to relying on external lights such as sunlight, because that induces some kind of variability. And since we are training this model entirely from scratch, it is not very robust to external conditions. So we have to train it. We have to be very specific on the conditions which we have used for the training purpose. Okay, so now let's copy this and let's run this. I've placed my cube now. Now, let's see how the inference is. I have recorded only 5 episodes, so I don't expect any extraordinary performance, but let's see if at least the motion is being replicated by a robot. So the question is, model doesn't have text input, but you mentioned pick up red cube and place in bin. So that is just a name which I have given as a placeholder for this task. It doesn't mean anything. It's just a name for the job. As you can see, it takes some time because I'm running it locally. So I think the model loading itself is time consuming. For people who have a good local setup, and if you have GPUs in your laptop, you have a high computing, then this will be very fast, I think. Yeah, I think we should be able to see it now. Let's see. So you can see at the bottom, it is loading the model now. It's at 0%. And the model size ends up being around somewhere around 80 million parameters. So it's not a big model. That's why you can run it locally as opposed to LLMs.
Recording episode 0.
See, it moves. But my webcam has fallen down. So that's why it's only relying on. Okay. Let me actually cancel this.
Stop recording.
So this is not a very ideal thing, right? If your webcam falls down or something changes,
Exiting.
right? So now let's see. So I'll again run it now. This time, hopefully, the view will be better. Ideally, we have to start, well, if you are able to reposition it in the same way, then you don't need to start the data collection again. But now I have fit the webcam, so it's likely that,
Stop recording.
okay, this happens because the name I have to change. So now it will again start, and this time, hopefully, the webcam view will be very similar to what I had during collection of the data set. Let's see.
Recording episode 0.
Yeah, I've not placed it properly. I think it was somewhere like this. Yeah. So you can see it's trying to grab the object. Does something drastic, and so this is not a very ideal setting, but even in this setting, it's somewhat able to follow the movements. And since it's autonomous, it will keep going. You don't have to stop it. So I again want to record this because to give it a best shot, let's see what happens with.
Stop recording. Exiting.
Okay, let's see now. I think this time it should be much better. There is an interesting comment in the chat where it says that you can use device MPS so that it uses Mac's native GPU accelerator. Yeah, that's a great idea. I think it's worth trying it out.
Recording episode 0.
So it's going towards the cube. Let's see what it does. It does try to pick it, but does not completely grab it because of the orientation. And then moves towards the left and tries to drop it. And then comes back. So kind of understanding what we are trying to do. Let's try to again position the cube. The reason it keeps on going is because it's trained to look at observations and map it to actions, right? So yeah, I think now the episode has ended. So I want to again run this and see
Stop recording.
for a different position of the cube how well it performs. This time I'll reorient the cube in a very specific way.
Exiting.
Okay, let's see. We'll try it again. So the good thing about autonomous control is that you can change the
Recording
location of this
episode
cube
0.
in between, then it will move accordingly. So let's see now. It's opening up at the gripper arm, and it's moving towards the cube. But because we did not collect the locations of the cube in that position, it doesn't know what to do. And this one it will grab. Oh, great. I think it grabs it. Almost grabbed it. Actually picked it up, but then it fell out. But it again goes and tries to grab it, which is the plate. And then it goes back. You can now, I'll just move it, take it close. Let's see what it does. Again moves, opens the gripper. And yeah, I think the episode ended right now. Okay, so this is how you run the inference. And the robot by default was going here because I think this is where most of the training data was present. And it tries to grab the cube from this location. So I'm almost inclined to try it one last time because I think it might get it from that location because those were the points we covered during training. And because we did not cover slightly interior points, I think it gets confused on what to do over there.
Stop recording.
I'm going to slightly move it a bit far.
Exiting.
Okay, let's see. I think this one will be closer than the last one. I hope it gets it this time.
Recording episode 0.
Okay, it's lifting up and it has opened its gripper quite early. Because that is how I trained, I recorded the data. It has learned to go to the red cube actually. In all the inference, it learns that. But I think the gripping part is where, yeah, it went off track. Let's move it closer, see what it does. I think it will move to the right now. It will reorient. Yeah, it does reorient. Again, opens its gripper. Might move slightly to the right again. Yeah. It's almost like it's pushing the block now. But I think it's with more episodes, this will definitely get better and it will learn to grab the block. You can see it's understanding some things which we can see by interacting with it. So the policy works in some aspect, but with more episodes, I think it will get even better. And I have a lot of extraneous data here like cables, etc. But still it's able to go to that red cube, open its gripper, and then close it and move towards the plate and come back. That whole process it has learned in just 3000 steps of training where the loss didn't even go down that much. So with a lot of modifications, I think firstly in the number of episodes and secondly in the number of steps where we can bring down the loss even more. Okay, so quickly summarize, there are three steps to get this robot to work. The first is the installation where we have to
Stop recording.
install the learnable library. Before the installation of learnable library, we need to set these arms properly. We need to connect the USBs to the extension and the charger, the charging cable also. And then after that, we need to install the learnable package. There we might run into some issues, which I explained how to overcome those. And we have to calibrate the motors. We have to run
Exiting.
teleoperation. And after that, we are ready to set the cameras. Now, setting up the cameras is crucial. One gripper camera, as was used in the paper, and people use at least two cameras, one as the top view, which you can see over here, and one in the side view. For our training, we are only using two cameras right now, but you need to identify the index of those cameras because in recording the data set, that index becomes crucial. And then you actually record the data set, you record it in different zones so that you cover multiple zones within your table so that the policy becomes good at generalization and covering different spots. And the lighting conditions should be emulated, whatever you have in the training. Same thing you should keep during inference also to maximize your chances of success. Uh, with just a limited amount of training, I was able to get it almost working. But if you increase the number of episodes and if you decrease the loss even further, it will be even better. Then for training, we used runpod. It was very simple to set up a runpod account and it was very, very fast also. So we did not face any issues there. Runpod makes it very easy to train using GPUs and it was very fast for us. And then we trained the model, uploaded it on Hugging Face and ran inference. So it worked out. These are the three phases: hardware installation, training, and inference through which the policy works. And now we get a sense of what imitation learning is, right? We do some demonstrations and the policy learns from them. And we started with deep generative modeling in the first place because the problem of multimodality not being taken into account by point estimate policies. So we want a policy which can learn different modes of moving the arm, which is what ACT is an example of. It's a variation autoencoder. So today was a slightly a longish lecture. It yeah, went a little bit ahead of time, but I hope this becomes a self-contained lecture for you to run this ACT policy.